You're listening to the Uptime Wind Energy Podcast, brought to you by BuildTurbines.com. Learn, train, and be a part of the clean energy revolution. Visit BuildTurbines.com today. Now here's your hosts, Alan Hall, Joel Saxum, Phil Totaro, and Rosemary Barnes.
Welcome back to the Uptime Wind Energy Podcast. I have Phil Totaro from California and Joel Saxum down in Austin, Texas, and Rosemary Barnes will join us shortly from the Southern Hemisphere. A number of news articles this week that we want to talk about. Statkraft, let's lead off there, up in Norway. So Norwegian energy giant Statkraft has announced it will withdraw from the upcoming floating wind tender for the Utsira North area as part of a broader cost-cutting strategy. The company, which is Europe's largest renewable energy operator, will also halt new offshore wind project development to focus on what CEO Birgit Ringstad Vartdal calls, quote, near-term profitable strategies, unquote, like solar. No, come on, solar, wind, there we go, and batteries in fewer markets. The decision follows Statkraft's earlier announcement in May to stop new green hydrogen developments, signaling a strategic shift toward more immediately profitable renewable energy investments. Phil, does this slow down some of the offshore wind work, particularly up in Norway? And it does seem like floating will be the future here. But if Statkraft's not going to be involved and it's right in their backyard, what does this say to the industry?
It doesn't send the best signal, but it's also coming in a time when, as we record this, the Norwegians just released 4 new wind lease areas with potentially up to 20 different project sites. So it seems like there's a lot of enthusiasm, and obviously they've got the wind resource up there to be able to do a lot of floating offshore wind. If they can work out with their military, the radar interference and all that, there's no reason they shouldn't want this capacity, because it's, power that they can use to balance their hydro and power that they can offload to, other Scandinavian countries, because there's plenty of transmission already, and they're already planning on building more. So it's just whether or not they have the appetite to put the market mechanisms in place to actually support these, these tenders.
I think appetite's the right term here, Phil, when you say that, because as the CEO is saying in this article, we're going to focus more on near-term profitable technologies. So doing things that they know make money, that are proven to make money. We all love the idea of floating wind, which is what they're pulling out of this project, your floating wind project. However, nothing's really so sussed out yet. Nothing's really sorted. There's not a specific foundation that works best. There's not an interconnect that works best. There's not a turbine model that's out there like, this is the one, this is what we run with. You don't have support from major OEMs like, do we pick a Siemens one, or a Vestas one, a GE one for offshore, like we have for fixed bottom offshore. So I get it, like in we're in a stressed capital market where we're still sitting on high interest rates, and everybody wants to do something that's more profitable for them, that's proven right now. In my mind, is a good strategy. It would be, you don't want them to pull out of it. You would love to see some of the big guys put some of their R&D budgets and keep this floating thing moving, because that's a good move for the future. But I mean, it's all about making money and de-risking yourself. So, it's understandable.
Well, Vargroen is still involved in that Utsira North effort, and they're working on one of the larger floated wind turbine projects off the coast of Scotland.
Greenvolt, right?
Yeah, Greenvolt, right? And I'm wondering if Statkraft feels like the technology isn't developed as far as they would like it to be, and companies like Vargroen, which are really heavily involved in floating, are going to do the dirty work, and then everybody else is going to follow behind their lead.
Yeah, that could be, right? Because that's what's needed. Someone needs to go and put the money into this, but it's going to be risky, right? So it's what's your risk appetite? And if we're talking about risk in offshore wind, I mean, we've seen what's happened in the last 6 months, a year. So someone has to really, I guess the joke term in Wisconsin, we say, is pull up your big boy pants and go make this happen. So maybe that is of our ground. We've spoke with them on the podcast, and that's what they're focusing on. So maybe it takes someone like them to really make this thing happen.
Well, Vargrun's at the minute is discussing what type of turbine they want to put offshore. This is where the Ming Yang discussion comes into play, because Vargrun is, I don't know if they've selected them or down selected Ming Yang as one of the potential providers of turbines, but that's created a lot of chaos, at least temporarily in the UK, because the United States is super concerned about a Chinese wind turbine off the coastline of the UK.
Joel was talking about de-risking. And originally for this project, Statkraft was partnered with Ocean Winds, which is uh, EDPR and NG, and Acre, which was originally mainstream offshore when they originally started making the bids. And those two other groups, or three technically, if NG and EDPR, as well as Acre, they had already previously pulled out of this partnership. So you don't have this de-risking capability anymore. Statkraft was basically having to take this whole thing on by themselves, and they probably weren't finding any other partners that were particularly interested in diving in with them at that point. So I think them pulling the plug. It's almost like what happened, when with the Atlantic Shores project in the United States. When one partner pulls out, the other partner can't really make it a go. So the other partner is going to pull the plug, and then the whole project is basically dead. So that's just what happens, unfortunately, when you're not able to de-risk the project.
Over in the UK, they're de-risking a couple of larger projects. The Crown Estate has selected Equinor and Gwent Glass, which is a joint venture between EDF and ESB. They've been selected as the preferred bidders for floating wind projects in the Celtic Sea. Now, each developer was awarded 1.5 gigawatts of capacity, which is quite a bit, in their respective development areas for an annual option fee of £350 per megawatt. And the Crown Estate launched this fifth offshore wind leasing round in February of last year, originally offering 3 areas with up to 4.5 gigawatts total capacity. This is a big deal because you're bringing in Equinor and EDF, ESB, and it's going to really expand the amount of energy produced from floating wind. So although Statkraft is not going to be involved up north off the coast of Norway, a bunch of developers are going to be really involved off the coast of the UK. This has implications. I think the floating wind difficulty, at least the engineering difficulty, is going to be solved by the United Kingdom and maybe France. Don't you think, Phil?
Yeah, I mean, France has had, a couple of demonstration projects now for a little while, and they just got their first kind of, people still refer to it as kind of pre-commercial. It's like 30 megawatts worth of floating offshore capacity now with, a small project. And the second one's on the way. Japan's been investigating floating foundation technology. We've even had some stuff here in the States with the University of Maine looking at this. I mean, everybody's been looking at floating for 15 years. But the reality of it is there's plenty of technical solutions out there. None of them have achieved commercial viability yet because nobody's been willing to invest in scaling it up. And the fact that we haven't really directly involved the oil and gas companies who have, abundant experience with tension-like platforms still confounds me because, if you leverage the capabilities that they already have, you're going to get them more interested because it's going to give them an opportunity to leverage the technology that they already have heavily invested in that we can use for a floating offshore wind platform. So it's always been a bit head scratching the way that the industry's gone about floating, but absolutely, the UK, France, and Japan are probably the three likeliest candidates to do the majority of the risk reduction on that technology platform that's going to allow it to scale up and become more useful in the rest of the world.
Phil, I completely agree with you. We've been talking about that for a while, right? Why are some of these companies not getting involved? And the one that I have seen get involved is French company. Technip, used to be Technip FMC. They invested in X1 Wind. And if you know anything about Technip is man, when they were with FMC, they had 50,000 employees worldwide, but they do some of the largest offshore oil and gas installations around the world. Deep water, shallow water, construction, you name it. They even have their own vessels to do construction. Like, they're that big. And the engineering power that they have is massive. And they're a French company. So French, EDF, the Northern France kind of demonstrator projects. And what it was, Technip Energies invested in, was X1 Wind, X1, like one of the platform things. Like, they had about 10 or 20% of that thing. I don't remember exactly what it was, maybe 15% of it. But I expected some of that, like those plays to continue on. Some of like, the SciPems and more of like the acres and that to get involved more heavily on the innovation side, because that's what they've done in oil and gas, right? They've done the pre-feed work to make these things happen in deep water. So they have the engineering prowess, the experience, and the know-how to do these things. It's just kind of like, where are they at? Why aren't they playing? Why aren't they playing at a bigger level? That's my question.
Well, is it happening behind the scenes and we just haven't heard of it yet? Because that's the feeling. For as much money as being poured into these projects, there must be a technical solution that is at least validated on the engineering side, you'd think.
I did see a press release just the other day. There was a company called Encomara, and Encomara was making basically what they described as a USB-C type connection for mooring and power connection for floating wind. So it was like a universal, like, this is how you plug it in, this is how you connect it, it moors it, it sends power, controls, all this stuff. Great technology. They were just purchased, I think, by Aurora Energy Services. And Aurora is another one of those players that does a lot of dev work offshore. So you're seeing some of these technologies get to a certain level, and I don't know what that technology was, if it was TRL4, TRL6, I don't know. But they were scooped up, and now that IP rests within a larger offshore development company that can make a move with some of these things. So there is some of that stuff, like you said, going on behind the scenes, Alan, I'm sure. We just haven't seen it that much. If anybody wants to talk, call us, because we would gladly have you on the podcast.
It does seem like there's a number of transactions happening that are quiet, that when you piece them all together, looks like a solution. And I'm glad to hear it. As wind energy professionals, staying informed is crucial, and let's face it, difficult. That's why the Uptime Podcast recommends PES Wind magazine. PES Wind offers a diverse range of in-depth articles and expert insights that dive into the most pressing issues facing our energy future. Whether you're an industry veteran or new to wind, PES Wind has the high-quality content you need. Don't miss out. Visit peswind.com today. If you haven't downloaded your latest PES Wind magazine, you need to do that now. It's free, and it's full of great articles. I want to highlight one from FT Technologies. So if you haven't heard of FT Technologies, and I don't know, you've been living under a rock, FT Technologies makes I wouldn't call it an ultrasonic wind speed sensor, but it uses sort of ultrasound to create a standing wave that they can then detect wind speeds very accurately. So it doesn't have the little anemometer spinny piece to it. There's no moving parts, which makes it so elegant and simple, and it measures wind speed very accurately. In fact, it can measure wind speeds up to, Joel, now hold on, 200 miles per hour.
I hope we're not seeing those at a wind farm, to be honest with you. But I think that, though, there's something that's really important here that I would love to see more of components in the wind industry go to. Classical anemometer, I might say that wrong.
Anemometer.
They're moving, right? It's a moving part. Like, you see them, like you can buy the weather station for your house. It looks the same as the old school ones that are on these turbines that sit there and spin. You remove that O&M risk by using the FT technology sensors, right? There's no moving parts. They're not going to get affected by ice or snow buildup or heavy rains or like dust or like or lightning. There's no bearings inside of it to go out, right? So what they have done here is something that we should be focusing as an industry on. All things wind energy is low maintenance, something that just goes out there and works, and that's what I like to see.
There are OEMs that don't use FT Technologies anemometer sensors, which is insane.
Oh yeah, that would be in a turbine RFP if I was writing one.
Right, exactly. If it doesn't come with the turbine, you need to specify it. And if you're in a repower situation, You need to dump the spinny anemometer thingy and put FT Technologies on your turbine, because who wants bad anemometer wind measurements? Joel, you and I've seen it. If you go to the O&M buildings, a lot of times there's a whole pile of broken anemometers of the spinny kind, because they either fail from lightning, or the bearings have gone bad, or something has happened. Why would you even mess with it? Just buy the right technology. It's proven that they've been around a long time. FT Technologies. Read the article. Go to PES Wind. Download your copy of PES Wind magazine. You won't regret it. Swiss aerial robotics company Valero has raised $23 million in Series A funding to scale its autonomous inspection robots for industrial infrastructure. Now, Joel, you have visited their facilities in Switzerland, correct? And we've had them on the podcast. Valero makes the drone that can do ultrasonic measurements, but also can do resistance measurements on your lightning protection system. The robot is pretty cool because it kind of can orient itself in any direction, and then it can apply force on sensors, which you totally need, so it can replace a technician. The approach is really slick. $23 million is a lot of money. That's would say there's a reasonable growth pattern for Valero to receive that kind of funding.
Yeah, absolutely. I visited the team, like you said, I think it was last spring. I was over in their offices in Zurich there. And I'll tell you what, $23 million is going to go a long ways for this team. They had a great office set up with kind of the front office, meeting spaces, and a lot of tech room, right? A ton of space for developers, a really cool glass enclosed kind of test facility where you could watch the tests real time as a viewer through glass, and they're flying the drones inside. A lot of really neat things. But one of the reasons that they're of course going to be able to expand really well is we like what they do for wind, right? They have the LPS inspection technology where it's semi-autonomous. They can go up. That once they see the receptor, they can just hit a button and it will semi-autonomously orient the drone in the right way so it gets the right pressure on the blade. Fantastic. They can also do NDT, but we're just talking about wind because that's what we like them from. They do a lot of things for all kinds of industrial inspections. So oil and gas, traditional power, you name it, manufacturing facilities. They can inspect it all. So kudos to the team over there. I know they've been making some inroads into the States. We've heard a lot about some of the LPS testing they've done in the wind sector. And yeah, like I said, $23 million, a lot of money, can go a long ways for these guys. So congratulations.
Where do you think the majority of their income is going to come from now? Is it going to come from oil and gas and all the measurements they're doing on steel tanks and that sort of product?
It's NDT and oil and gas. And the way that they've set the Valero as a company, the Valero T drone, it's really set up for NDT well because it's a platform, right? So it's a platform. You can put a phased array unit. You can put a different, single phase unit on it. You can put all kinds of different technologies, and they are actively integrating all kinds of different technologies. Because if you know anything in the non-destructive testing space, it's all about like, hey, we've got this problem, we need this type of kit. We got this problem, we need this type of kit. We need to be able to see through paint coating, so we need phased array. We're on bare steel, so we can use this. We're on a composite, so we need this. And they've done a really good job at setting that system up to be able to utilize all of those technologies. So yeah, I think that they'll, and let's be honest, oil and gas companies pay more. So that's a good space to be in.
So let's put this in perspective with the Arones, was it Series B with Arones, and then with Valero getting their Series A. For the longest time in wind, there wasn't, the last couple of years, there hasn't been a lot of investment from outside companies into wind-ish companies, but the robotic sector still seems to be humming quite nicely.
Don't forget $20 million for SkySpecs last fall either.
Exactly.
So you're seeing SkySpecs with new drone technology. They got the new Foresight drone out. They've got their internal crawlers moving. Arones has got internal crawler Gen 3, I think it is. Plus all of the crazy things that they're doing, robotics, LEP, blade repair, AI integration, really cool stuff. So Y Combinator, of course, if you're in the startup space or startup networks, you kind of know Y Combinator. They're a cream of the crop type platform to launch. They put out a list every year that says this is what we'd like to see from people applying to the Y Combinator. I think they're on like Y Combinator cohort 20 something or whatever. And if you look at that, it was AI and robotics every request. That's what they wanted. AI and robotics, AI and robotics. So it's not just AI and robotics in the wind space that we're seeing the Sky Specs, the Valero, the Roans getting the money. That is a larger trend in the investment world.
What do you think the market cap is for the robotic repair business in wind alone?
It depends who cracks the ability to do Cat 5 repairs first.
You think that's going to be the marker?
I think if you can, because right now you can't do a robot as it sits today. I don't care whose robot it is, cannot do everything a technician can do. So you still need technicians, and that will be that way for a while. I think it's going to be hard to get to the point where we're doing Cat 5 robotic repairs. I think it's going to happen for sure. I think probably Arones is the closest, right? But once you can do that,
isn't the Arones approach is to catch problems, especially blade repair problems, at sort of Cat 2 and Cat 3, and not let it to get to Cat 4 and 5 because the robotic solution is so much simpler?
Well, I think that's everybody's solution, right? Everybody would like to do that. Catch it at Cat 2 and 3.
The problem with the Cat 2, Cat 3 catch is that you just don't have enough technicians to go out and do it. And the pricing isn't right. And we might as well discuss it because it's the discussion of WeatherGuard at the minute is how much quality is going into some of these repairs in the States. I will leave the rest of the world out of it for a minute. I think in the United States, the quality varies quite a bit. And the composite repairs, I'm not supremely confident that we're getting the best repairs that we could for the money we're spending. Maybe that's a way to phrase it.
Well, but is that because they are triaging?
I don't think that's it, Phil. I think it's a skill level and just a knowledge.
So that's what I want to bring. I'm going to mention our friend Alfred Crabtree, Blade Repair Academy, because he knows a ton of this stuff, right? And he's told me, basically for someone on ropes or someone in the field, 5 years is about max. You see someone that's been on ropes for 7, 8 years, they're a dinosaur, right? So, but now let's switch that to something simple that we all understand: a car repair technician. So you bring your vehicle in to get fixed. A lot of times that technician's been wrenching for 15, 20 years. Those are the people that know the stuff, right? There's a bunch of experience there. They're not going to throw someone who's been, working on cars for a year to switch your engine out or to do but that happens, right? Like I talked to someone in the field the other day, and that was a rope tech, and this was his second summer. This gentleman was fantastic. Met him in the field. He walked out of their rope access exclusion zone, did a JSA before we even approached. He was awesome. However, second year technician, and he was doing a Cat 4 repair. That to me is like, whew, that's a little scary.
And in Europe, they don't tend to treat it that way. It tends to be a much longer cycle of working in wind turbine blade repair. You see a lot of technicians come over from Europe that have more than 5 years, generally speaking, and those are the technicians get assigned to these more complicated tasks.
There's a huge difference in working conditions between the US and Europe. Actually, one time when I was doing a training course in Sweden, I think it was like an advanced hub rescue training course, there was a guy there who had worked as a wind turbine technician in the US, and he was upset because he didn't get enough time with his family. Basically, he was just on the road all the time. So he took a job in Sweden instead. So he would be able to see his family in America more, because he got, 6 weeks annual leave and a lot of public holidays and all that sort of thing, proper sick leave as well. And, they are actually in Europe worried about your, making sure that you don't wear your body out in 4 or 5 years doing a hard job. It's still hard work there. It's not like it's ever going to be an easy job, but in general, they care more about making sure that you don't get sick from work, and even often that you enjoy your work, like that's actually an important thing. So you can argue about where Europe is at relative to the US in terms of competitiveness and, the hunger to get, innovative startups to work. And so I don't think it's like Europe is all better and the US is all worse, but it doesn't surprise me at all that you would have a shorter lifespan in a hard job like wind turbine technician in the US compared to Europe.
Don't let blade damage catch you off guard. Eelogic's ping sensors detect issues before they become expensive, time-consuming problems. From ice buildup and lightning strikes to pitch misalignment and internal blade cracks, Eelogic's ping has you covered. Their cutting-edge sensors are easy to install, giving you the power to stop damage before it's too late. Visit eelogix-ping.com and take control of your turbine's health today.
Alan asked the question before, how big is this market? If you're just talking about inspections, that's a few $100 million a year. But like Joel mentioned, if you're talking about being able to do repairs all the way up through Cat 4 and eventually Cat 5, that's going to end up being worth, several billion. I mean, just blade repair alone in the United States is on an annual basis about 1.2 to 1.3 billion a year. So, there's certainly a market for this.
I think, Alan, you started this conversation about, what are we seeing in the field and is it up to snuff? And I got to say, generally, no. From my seat, no. I don't think that. Yeah, I don't think that we're getting the best quality in the field that we should, in general.
Which opens up the door to robots.
I do anecdotally hear people, concerned that the same blade that was repaired a couple of years ago is now having a repair in a very similar place, and but no one's ever really sure if that's the exact same problem or something similar because they don't document well enough. I don't think it's a problem that someone with 2 years experience is doing a Cat 4 repair. That to me, there's nothing wrong with that if the processes are well designed and like the work instructions are all good and the quality control process is appropriate. Like category 4 versus category 2, it's only usually, a difference in the number of layers that you've got to remove or just like how important it is that you get it right. But honestly, you should be getting it right every time, no matter what, how severe that the damage was. There's no reason not to. It's not faster really to do a bad repair than a good one. Well, I guess it depends on what kind of bad repair you do. You could do you could just whack a Band-Aid over the top instead of grinding away. I guess that would be faster. But anyway, that aside, I don't think that there's any problem with that per se, but the implementation of it, if it's not right, then you could see problems. You don't want processes that mean that you have to rely on individual judgment and remembering to do the right thing and, noticing something that you wouldn't, you're not told to notice in the work instruction. So I think that it's probably processes that are to blame if you've got problems with repairs needing to be redone rather than specific repairers.
But it's the same breath too, Rosemary. Like that's great technician wise, but that means that engineer who designed the process needs to be properly educated, and knowledgeable about it, and the process. I can almost guarantee you at these ISPs that there's not a process engineer reviewing the QA/QC methodology and stuff. It's kind of like, this is just how we do it.
The repairs should be certified.
What does that mean?
It means that the repair method has been certified to bring the blade back up to design intent.
OEM won't even share the instructions.
Right. They won't even tell you what the layup is or the materials.
It's definitely not happening.
And then for small repairs, then you don't need OEM involvement. There's just there's standard chamfer angles and there's lots of standards involved in how much you need to overlap and all that sort of thing. So for a small standard repair, everything is straightforward. For something complicated where it's in on the main laminate or it's over a web or it's really huge, you simply do need engineering to make sure that that's going to bring your blade back up to design intent. And if you can't do that, then that's a big risk you're taking. And I hope people are doing that mindfully. The money that they're saving by going that route is worth the risk that adds.
Yeah, a lot of them are basically like once you get a cohort to agree, like the ISP's engineer says this is how we should do it, and this is how I've done it in the past, and someone from the asset owner says, that looks about right. That's what I think we could do too. And they go, all right, do it.
Are we measuring the quality out in the field somehow?
I would at least want to see people keeping track of where, like what span-wise and chord-wise location was a repair done and when, and then, keep that in a database and then making sure that the same ones aren't coming up over and over. I think that would be a really good step to see if you've got a problem. I don't think that you can really start to tell if you've got a problem until you're at least tracking where the damages are across your fleet, and you are going to need some sort of statistical analysis to see if what you're seeing is random chance or if something is going on.
Isn't that what SkySpec's Horizon system is doing? Is tracking repairs and then looking in the future, because they're doing all the inspections, they can see if that repair is held up or not. And I wonder if there's any numbers on the amount of repairs that have failed over time.
I'm sure. I think at the bigger operators, the more advanced ones, right? Like your Nexteras, your RWs, your EDFs, they're tracking this stuff. EDF for sure. We know Sagala, they're definitely doing that. But the mechanism that I've seen I like this one. And it's not directly an engineering one, and this is the difference. COPQ, cost of poor quality. So as an ISP, if you're tracking the amount of times you have to go back to fix something from a quality issue, when a lot of ISPs will give a 1 year or 2 year warranty against workmanship on their things, they're not going to warranty a failure, but they'll warranty something in general. That when you start to track that metric of cost of poor quality on a commercial side, then you start to see, okay, if we do have an engineering problem or not, you can track it that way. So it's a checks and balances, judicial, legislative kind of thing, right? Where the commercial side can check the engineering side. And if the engineering side hasn't been checking themselves, that COPQ is a good metric to watch it.
Everybody has a certain amount of budget that they can spend on operations and maintenance on an annual basis anyway. And so it basically comes down to triage. And they'll decide, I guess what I'm saying is they'll do a repair and say that it's good enough. And it might not be like factory restored and factory certifiable like Rosie's talking about, but it'll be good enough to be able to get the turbine back up and running, because at the end of the day, they care about availability, not about the quality of a repair. Or if they're comparing the two, the availability is always going to win.
Joel and I have been talking to a couple of people about this. When the production tax credit finally rolls off and repowering stops at 10 years, does that change that type of repair where they'll just put a Band-Aid on it to get to the 10 years and replace the blade set?
Yeah, because then you need ROI out of your repairs.
100%. And we're going to see what happens. Although keep in mind with the PTC, I mean, we've been here before where, it goes away, it comes back again, and there will be a new administration at some point and a new Congress. So just keep that in mind. But in the meantime, if they're talking about ramping it down, that is necessarily going to reduce the amount of repowering projects that are commercially viable, because some repowerings, just if they don't have the full value of the PTC, they can't do the repowering. So that means they're going to either have to life extend, they're going to end the project either early or, at the planned end of asset life. And that's going to be about it. And you're going to hope that you get something. I think the reason that we'll see some life extension is because asset owners are going to want to try to wait it out to get to another Congress that's going to extend the PTC again. And that's what everybody's kind of banking on at this point.
Let's just play this out just for a minute, because I want to go back to the market cap discussion. If PTC rolls off and the repowering rolls off, does the market cap for robotics then go up significantly?
Yeah, because you need it. That's what we're in a bad spot right now. We lose PTCs, and you can't repower and stuff. There's a lot of, I'm not going to say distressed assets, but looking across the bridge at distressed assets out there that have been ran or managed in a certain way, that this is just how we do it in the States. That all of a sudden, we're not going to be able to repower these things, and we got to run them for 20 more years. And there's a couple companies out here that have assets that have been around, a lot of assets that have been there. Constellation is one. They have a lot of assets that were COD 08, 09, 2011, 2012. They've been running them for a long time without repower. That someone like that may be someone to look at to say, what's the strategy here for the long-term play, because it could change.
Yeah, although they also have PPAs that are like 40, 50, $60 a megawatt hour. If you only have like a $20 a megawatt hour PPA, then you're probably not. I mean, you're freaking out right now because if you don't have the ability to do a repowering after 10 years, and replace the blades and refurbish the gearbox and everything, you're kind of screwed. So that's a big deal.
The wind farm of the week this week is Babbitt Ranch, which is a NextEra and Salt River project, which is, and this is kind of going back to we were at ACP over in Phoenix. This wind farm is north of Flagstaff. You don't see a lot of wind farms up there, but it's got some cool factoids about it, right? So it's 50 GE 3.4 megawatt 140 meter rotor machines, and it is on a ranch that's been in a family operation since 1886, which is pretty cool. The timeline looks like initial announcement of this farm was in January 22. Construction began in March of 23 and full operation mid 24. So this thing's about a year old right now. So that it's on the Babbitt Ranch. Like I said, it's been a family operation since 1886. The fourth generation leader of the family, his name's Billy Cardasco. They've always been thinking about balancing ranching, conservation, and innovation. So they've been looking into wind energy and renewable energies on this ranch for a while, and they finally pulled the trigger. And part of it is the Salt River project is the local power consumption company, but they're also going to be a Google data center in the same space. So Wind Center is going to bring about $9.5 million in tax revenue, along with 250 temporary construction jobs, which is pretty cool. And it's going to power some data centers, which helps Google's net zero emissions goals as well. So the Babbitt Ranch wind farm up in or down in Arizona, you're the wind farm of the week.
Oh, that's a really interesting wind farm. That's an old farm for Arizona, right? 1886. That's a while ago. That's cool. Well, this is going to do it for the Uptime Wind Energy podcast. Thanks for joining us. We'll see you here next week for more adventures in wind.